Everyone, in this video I am going to discuss logit and probit models, where we have dependent variable, response variable, outcome variable as binary variable. So far we have been discussing dependent variable as a continuous variable. So whether you'll get into college or not, whether a person smokes or not, and there are many other examples, whether you are in labor force or not, whether you are at a managerial position or not, whether you are in a shopping mall or not, you are union member or not, retired or not. No. Before this, all these variables are dummy variables, were only as an explanatory variables. But in this case, we are considering dummy variable, binary variable as dependent variable. So whether I will buy a car or not depends on my income, on my age, on my gender, how far I live from city, what is level of public transport in my city, and many other factors. So response variable, outcome variable, whether I am going to buy a car or not. So here we are going to explore Home Mortgage Disclosure Act data. This is very commonly used data in many econometric books, that whether a loan denial or approval is function of race, whether race is a determinant of loan denial or loan approval, whether people who have applied for loan in US, whether they were denied loan on the basis of their race. So if you just look at aggregate number, 27% black people were denied loan and 7%, 9% white people were denied loan in this data. So should we consider that there is racial discrimination because difference between 27 and 9% is very large? There can be many other factors for which we need to work out. So here in this case, what we are going to say that our dependent variable y is your binary variable, x may be continuous, x may be binary. What will be the interpretation of change in x leads to change in y? When y was continuous, it was okay, but in this case we have y as 0 or 1. As 0 or 1, y hat equal to 0.26. So it means if black is 1, white race is 0, it means 26 out of 100 blacks or 26 out of 100 applicants were denied loans. So we are going to understand this concept, that what is how we model our data when your dependent variable y is binary. So you can have y only two values, either y is 0 or y is equal to 1. So expected value of y is equal to y into probability of y plus y into probability of y equal to 0. So y have either value 1 or y have either value 0. So this will be probability of y equal to 1. So the expected value of y, which was an average regression model in our routine, is now probability that you will observe y is equal to 1. That is your expected value of y given x. That is equal to probability that you will observe y equal to 1 for a given value of x. So what do we say? That probability of y equal to 1 for a change in x minus probability of y equal to 1 for x. So this is basically beta 1 hat. This is beta 1 hat, and beta naught hat is y bar. So now we are going to see that we have data where either you are denied loan or your loan is approved. Now you see, there are many other factors. At the moment I am excluding race, but you will either observe this 0 line or you will observe this 1 line. In data you have either mortgage denied or you have mortgage approved. Obviously, it's a function of payment income ratio, how much loan I have to pay as per my income ratio. So lower the income ratio, higher the probability that you will observe zero, that is loan approval, mortgage approval. As your payment income ratio increases from 0.3 to 0.4, you will see more black dots on 1. This is sample data, basically not all dots are plotted here. So you will observe more dots here. So after a certain threshold, you see more dots are at 1 and that is loan denial, and few dots at loan approval. So how we model this data? You can have three models. One is your OLS, which is called linear probability model. But linear probability model has some demerits. First of all, its probability can be less than 0 or probability can be greater than 1, which is not possible as per probability axioms. Second, you have a linear model. You have a linear model means if your payment income ratio changes from 0.1 to 0.2, you have same probability of loan denial if your payment income ratio changes from 0.6 to 0.7. Obviously, when your payment income ratio increases after a certain value, probability of loan denial, mortgage denial basically will increase at a very high rate. So this should be a non-linear model. And to overcome these two problems and heteroscedasticity problem, we use logit and probit models. We use logit and probit models. These are the things which you can see for OLS, the probability that you will observe y equal to 1, given payment income ratio 0.3, probability you will observe y equal to 1 given 0.3. So these are the things which you can observe, and we say that when your payment income ratio changes from 0.3 to 0.4, you have mortgage denial probability 6.1%. This is and when you add a black variable, basically main variable of interest in this data is that whether there is racial discrimination. So this is your variable of interest by control, and these are your control variables. So when you include black variable as well, so you see that this difference is 17.7%. That is, black is denied mortgage 17. Blacks are 17% more than white for mortgage denial. So there are advantages and disadvantages. As I mentioned, that probability may go more than greater than 1, less than 0, heteroscedasticity problem, linearity problem. So in order to overcome these problems, we have probit and logit regression models. In probit models, we use normal distribution. In logit model, we use logistic distribution. Otherwise, they are very similar to each other. They basically there is a link function which basically ensure that probability remains between 0 and 1. It enforces probability to remain between 0 and 1. As such, there is no difference between logit and probit model these days. Before this these computing facilities in 70s, 60s, logistic distribution was more convenient to calculate. Its probit model based on normal distribution has very difficult cumulative distribution to calculate. So we used to prefer logistic models. But today you see these black and blue lines are so close to each other that practically there is hardly any difference between the two. So you can use either probit model or you can use logit model. There is absolutely no difference between the two. So we just go and see probit model. As I mentioned, that it is based on normal distribution. It is based on normal distribution. So this is our probability that y is less than or equal to 1 this is your cumulative distribution function, and you can calculate this beta naught beta 1x, and then you see by using normal area table you can calculate this probability that where does it fall. So if beta naught is minus 0.2, beta 1 is 3, x is equal to 0.4. Your payment income ratio is 0.4. So phi of minus 0.8, it means that area less than minus 0.8. So when we see this less than minus 0.8 area, that comes out to be 0.2119. So 21.1% is the probability that you will denied loan mortgage. So probability is between 0 and 1, and when beta 1 is positive, it means as x will increase, you will have high probability of mortgage denial. It is an S-shaped curve. That is, after a certain threshold, you will see more at 1, less at 0. So basically, if you have low payment income ratio, you will have more dots here, but after a certain threshold, you will see more at 1. One will observe only either 1 or 0 Basically, this probit model or logit model just calculate the probability of observing 1 or 0. If it's greater than a certain value, you will observe 1. If it's less than a certain value, you will observe 0. There are so many examples in political science, in social sciences, even in biological sciences. When you make a spray, some mosquitoes will die. After a certain threshold level of spray, more viruses will go down, more mosquitoes will die out. Okay, so you have this stata commands. We will discuss these stata commands in our workshop on logit, probit, linear probit models using stata. I will compare these results in detail during the workshop. Now, these probabilities are calculated. You see that when payment income ratio is 0.3, probability that you are denied a mortgage is 0.097. When it is 0.4, that probability that you will denied mortgage is 0.159. When it is 0.5, you will see that it will not be the difference between these two. That is, you have 0.1, 0.3 to 0.4. So you have and 0.4 to 0.5. So you see, change in x is the same here, change in x here. But probability of denial will not be the same because it's a non-linear model. It's a non-linear model. It's not a linear model like this. So you cannot have standard interpretation. You have point-by-point interpretation. So you can calculate it by using z-score, and you can add more values like black, and you can calculate these probabilities. I will explain all this process in my video on workshop using stata. These are all the probabilities. So probability that you will be denied loan, that if person is black and will be denied loan is 23.3%. If person is white with same payment income ratio, person will be denied mortgage is 0.075. So you see there is a big difference, 15.8% more probability that if a person is black will be denied loan. So but there are still many other omitted variables which we will discuss. Logistic distribution, logit model, this soft logit or if hard logit. So you can pronounce it in your own way. So this is logistic distribution, and the only difference is that we calculate it on the basis of logistic distribution. Results will be exactly similar as in probit model. So you see results of probit and logit model are very similar to each other, and we calculate, basically we use maximum likelihood function in using this logit model and probit models. So you can go through this mathematical theory of logistic distribution. So we try to basically maximize. Try to find out those values of the parameter which maximize the likelihood of this data. The data we have already in hand, and we try to find those values of the parameters under which these data are most likely. That is the concept of likelihood function. So you can go through this mathematics. I am not at the moment interested in mathematics. So you have probit models, you have logit model, probit models, that is likelihood functions are consistent, normally distributed, asymptotically efficient, and it's a property of large sample. Maximum likelihood estimation is a property of large sample. So whether they are unbiased or biased, that's not a clear property of this MLE. So probit model, you can calculate it for Home Mortgage Disclosure Act data, which I'll discuss in a short while. So instead of using R square, we use pseudo R square. It's just like R square, but it's not R square, because now you have basically either 0 or 1. It's not a continuous variable. So now we discuss this. What are the variables in Home Mortgage Disclosure Act data? The number of variables we have. So you see payment income ratio, housing expense to income ratio. What is basically your housing expense and what is your total income? Loan to value ratio, that is, if I have a house, a property which I am going to get mortgage is of value $50,000 and I get a loan of $45,000. So it's very high loan to value ratio. If property value is $60,000 and I get $30,000 loan, its loan to value ratio is low. So personal credit history, consumer credit scores. So it's basically these are loan to value ratio low, very high, moderate credit score. What is your consumer credit score? All these variables play a role. What is your type of employment, whether you are married, what is your family status, whether you are living at one place for last 5 years and all that. So we have set of variables: payment income ratio, house expense to income ratio, loan value ratio, consumer credit score of this one, mortgage credit score is another variable, public bad credit record is another set of variables, whether you were denied loan previously or not, whether you are self-employed, single, high school diploma, unemployment rate, and our main variable of interest is race, and dependent variable is whether you are denied loan or not denied loan. So these are the tables which we will discuss in detail in our next video. In general, what do we see? That these are the coefficients. The first three are base models. Linear probability model, logit model, probit model, they have all same set of variables. These are base models, and then these 4, 5, 6, basically these are the variations of model 2 or model 3. As I mentioned that logit and probit are more or less same. So you can see the variation these three models. What do we want to see? Basically we have included these variables so that there should be no omitted variable bias. So whether blacks are denied a loan more than white, that's our main variable of interest. And what do we calculate at the end of the day? That if a person is black, all other things are same, all else equal, then he will be denied with a probability of mortgage denial are 8.4% more than if you are white race person. By using logit model, 6% is the difference. How we calculate this 6%? I'll explain in Stata video and R video. 7.1%, 6.6%. So as I mentioned, that these model for 4, 5, 6 are the variations of model 3. So in general, we see that there is a 6%, 7% difference of loan mortgage denial if a person is black, having all other characteristics similar to white person, that is, he is an average, all other variables are set at average value. So we'll discuss these results pseudo R square using Stata in our next video. Summary of these empirical results: that black is statistically significant in all specifications. So blacks are denied mortgage loan, denied mortgage more than whites. Logit probit, linear probit models provide very similar results to each other, and these results are very large. 6%, 7% is quite large number. So we say that there is racial discrimination, but there are internal threats and external threats to this model, and this data is about 1990. And what about today? That's an external validity. We'll explain all these things using Stata, using marginal effects, using adjust command, and much more. Keep on watching. Thank you. Take care.